Thanks for viewing this presentation. Today we will cover virtualizing the Oracle 11G database on Red Hat Enterprise Virtualization and NetApp storage. This presentation will cover explaining some of the technologies and concepts from both Red Hat and NetApp. We'll also share with you how the test lab was laid out, then we'll move to the specific problems that we tackled and illustrate the solutions with some recorded demonstrations. Finally, we'll cover some of the integrations that are being worked on between NetApp and Red Hat around Red Hat Enterprise Virtualization. As we move through today's session, I would like you all to leave today with the following ideas. RHEV 3 is ready for prime time. In other words, the stability, performance are able to support Tier 1 applications such as the Oracle 11G database. You can use some of the intrinsic features of RHEV to help mitigate many of the costs associated with deploying Oracle. You can also use some of the advanced features of NetApp Snap Manager for Oracle to not only back up and restore the database, but to also ease some of the frustration associated with getting support for a virtualized database, and use those same technologies to quickly deploy Oracle in a dev test environment. Before we go any further, we need to first talk about virtualizing Tier 1 applications. According to CIO Insight, the vast majority, around 85% of data centers, have virtualized non-critical applications, yet only around 14 or 15% have virtualized Tier 1 apps. This trepidation is due to some well-founded and some not well-founded fears about virtualizing Tier 1 applications like Oracle, Exchange, or SAP. I will say this, you're going to have to test this out in your own environment, especially if you're against the idea of virtualizing Tier 1 applications, and here's why. From a technical and business standpoint, you will need to know for sure what is going to work in your environment. Don't tell your CIO that it's a bad idea because you think it's not going to work. Perform your due diligence and know for sure. 10 years ago, it was not uncommon to hear how Linux was not ready to handle Tier 1 applications, that Tier 1 applications was strictly for Solaris, HPUX, and AIX. But then something happened. People started proving that wrong. Red Hat AS2.1 started supporting Oracle in some of the biggest data centers in the country. The point is not to automatically accept the status quo. But again, you're going to have to test this for yourself in your own environment. You will likely be surprised at the results. In some cases, reduced multithreading will increase performance and lower the utilization as there is less chatter between CPUs. Even if there's a slight dip in performance, you may decide that the flexibility offered by virtualization outweighs any performance dip. The worst thing that happens is that you tell your CIO, not yet, here is why, and here is what has to change before we do this. Now, let's take a brief look at Oracle licensing, which is our first challenge. For the uninitiated, Oracle licensing generally falls into one of two categories, Named User Plus and Per Processor. Named User Plus is generally used where the number of users and/or devices connecting to the database are easily identified. Per Processor is generally used where the number of users and/or devices connecting to the database are not easily defined. The number of processors and cores plays a factor in both scenarios. Additionally, Oracle has developed the concept of hard partitioning and soft partitioning as a means of determining how a license is to be applied to a server. In hard partitioning, not all CPUs are made available to the Oracle database, so only those CPUs must be accounted for. In soft partitioning, the database may not be using all of the available CPUs, but it has the potential to touch them all. In the realm of modern virtualization, Oracle has taken a hardline approach to this. Oracle considers RHEV and most other virtualization platforms to be soft partitioning. The only virtualization platform that Oracle supports under hard partitioning is their own OVM. So how does soft partitioning work in the context of RHEV? Simply put, if you are running a single virtual instance of the Oracle database along with your other virtualized apps on an 8-node RHEV cluster, Oracle would require licensing for all CPUs and cores on all 8 hypervisors. The reasoning is that the database could potentially touch any of the CPUs in the cluster. In the diagram here, we see that the virtualized Oracle instances, 2 of them, have the potential to run on any of the hypervisors in the RHEV cluster. For the sake of argument, let's say that each of our 6 servers has 4 quad-core CPUs, giving us 96 cores that we have to account for in licensing. Using Oracle's current rules, the list price of this would be 96 cores times a core factor of 0.25, or licensing for 24 CPUs at $47,500 each, times 2 database instances plus 22% maintenance fee for a total of $3.4 million. Let's see how we can mitigate this as best as possible. With a little planning, we now have our virtualized database instances, the same 2, running in a separate 2-node RHEV cluster. This is not a nested cluster or a cluster within a cluster. This is a completely separate entity. For the 2 quad-core servers, our equation becomes much more reasonable in comparison to the open cluster, as we're now licensing for only 32 cores instead of 96, and our maintenance fee is more reasonable in comparison as well. Our equation now becomes 32 cores times a core factor of 0.25 and licensing for 8 CPUs. This comes out to $380,000 times 2, or $760,000, plus a 22% maintenance fee, which gives us a total of $927,000. This is still expensive, but much more affordable as compared to $3.4 million. And again, this is list price. This does not take into consideration any discounts that your company may have available to it. So we've gained the benefits of live migration and better server utilization, but we're not punished for gaining the flexibility afforded with virtualization. Now let's move on to the test lab and how it was laid out. The layout of the lab was very straightforward. We had both RHEV-M and a Kickstart server running as virtual guests on a pair of RHEL 6.2 KVM hypervisors. This affords us the ability to migrate them as virtual machines, but more importantly, it allows us to provide our infrastructure level services a very high level of data protection. Additionally, it allows us to extend the enhancements around things like thin provisioning and NetApp snapshots to RHEV-M, Kickstart, and any other infrastructure applications. The single instance Oracle databases were running on RHEL 5.7 guests on RHEV-H hypervisors. Earlier in 2012, Oracle announced that they would certify Oracle 11G to run on RHEL 6. At the time that this lab was put together and the time that this testing was performed, Oracle is not yet certified to run on RHEL 6. In the RHEV data center, we had 2 RHEV clusters, one using NFS version 3 over 10 gigabit Ethernet for VM storage, and the other using Fiber Channel over Ethernet for VM storage. The NetApp controller was a FAS3170 running Data ONTAP 7.3. Finally, we had a separate physical server with the Oracle 11G running natively on 5.7. We'll discuss the use of this physical server a little later in the presentation. Our second challenge is around easing support for virtualized Oracle 11G instances. Let's start with a familiar situation. You have an issue with your Oracle 11G database that happens to be running on a virtual machine. If you're lucky, the issue is a known one, and the fix is immediately provided by Oracle support. If your issue is unknown or not immediately clear, then Oracle support may very well request that you recreate the issue on a physical server. Here is where a little planning and intelligent use of NetApp FlexClone within Snap Manager for Oracle can alleviate much of the pain and speed up time to resolution. With a little planning, having to reproduce issues on a physical host is no more than a speed bump. In this diagram, the production database is running on a virtual machine with the actual data mounted from a NetApp flexible volume. There is a physical server created in the data center that matches the RHEL version and patch level as well as the Oracle version and patch level. Using NetApp Snap Manager for Oracle, we quickly create a writable snapshot of the database volume and then mount that cloned database on the physical server. Not only does this make it easy to verify that the issue exists both on virtual and physical instances, but it's quick and painless to do. The cloning of the NetApp volume will typically take a few seconds, and mounting the clone volume a few seconds more. Once this is done, place your call to Oracle support. Your database is now running on a physical host, and you're one step closer to resolution. This is closely related to our third challenge, rapidly deploying databases in dev test and QA environments. The same cloning process that we use to ease Oracle support cases can be used to rapidly clone a production database multiple times for use in development. The cloned databases can then be mounted in the dev test environments without fear of corrupting the production data. The only additional storage space taken up is the delta between the new and old data. Ultimately, this means that working with large data sets doesn't have to overrun your storage capacity. Again, the clone volumes are writable zero-space snapshots of the original data, so they do not take additional space. If the developers break the dev database, the clone can be destroyed and a new one created in seconds. This also means that cloned databases can be used to test that other changes in the environment don't cause unintended issues. This also means that cloned databases can be used to test that other changes in the environment don't cause unintended issues. What performance gains do you get going from 4-core CPUs to 6-core CPUs? What happens when you move from 2 virtual CPUs in your VM to 4 virtual CPUs? Find out quickly by cloning the database and run your benchmarks without affecting production. So we've mentioned Snap Manager for Oracle, or SMO, a couple of times now. NetApp Snap Manager for Oracle is a framework that provides a streamlined approach to backing up, restoring, and cloning Oracle databases. Snap Manager for Oracle hides the complexity of database operations and underlying storage from database and storage administrators. Additionally, it minimizes the risk of data loss with increased backup frequency, as well as improving efficiency by greatly reducing restore and recovery times. It also provides time and space efficient database cloning for setting up dev test environments like we described earlier, and it also integrates with other Oracle technologies such as RAC, RMAN, ASM, DataGuard, and DirectNFS. If we look at the center of this diagram, we see a Snap Manager server that talks to the database that we're looking to back up and or restore. That database connects to the NetApp storage via SAN or NAS. SnapDrive for Unix, which also runs on Red Hat Enterprise Linux, is a core tool of SMO that eases provisioning and cloning of NetApp storage. End users can interact with Snap Manager for Oracle by way of a graphical interface or a command line interface. Finally, there's a small, separate repository that maintains a profile of the target database or databases. SnapDrive was mentioned on the previous slide as a core tool of Snap Manager for Oracle. The other critical tool is NetApp FlexClone. NetApp FlexClone software enables instant replication of data files, LUNs, and volumes without requiring additional storage space at the time of creation. On the left, we see that traditional cloning requires that entire thick data sets be created, which is costly to both time and storage. On the right, we see FlexClone. Instead of writing new data blocks, pointers are created that look to the original data. As new data is written against the clone, only the delta is saved to the clone. The original data set remains untouched and undisturbed. It is also possible to separate a FlexClone from the original volume or LUN, at which point the data blocks will be quickly copied over. Let's move on to our first demonstration, which covers the backup and restore of an Oracle 11G database. The first thing that we're going to do is log into the database and verify that it's running and it has all of the typical directories and files associated with an Oracle 11G database. Now we're going to verify that we can not only query a table, but write to it as well. Then we'll flush the buffers and rotate the logs. Here's the view of Snap Manager for Oracle, or SMO, where we create our backup. We're going to accept the defaults, and then we'll run the backup. As we can see, not only do we get a positive notification, but there is a complete log of the backup. Next, we're going to corrupt the database by removing the table space and verify that the next query fails. As you can see, this fails because there's no longer a table space to query from or write to. So we'll move back to Snap Manager for Oracle, then we'll use the backup that we just created to restore the database. Again, we'll use the defaults. Just like in the backup, we get a log of all of the transactions that occurred during the restore. Finally, we're going to verify that we can query and write to the database that we just restored. In this next demonstration, we're going to illustrate how easy it is to clone a database. We're actually going to clone that database from a backup. The first thing we're going to do in the demo is verify the original database, then switch over to the Snap Manager for Oracle interface. We'll create the clone from a backup and give the clone DB a name. Then we're going to double check the settings for control files, redo logs, and other parameters. We'll also make sure that the clone database is placed in a different Oracle home than the original database. And now let's trigger the clone. So not only are we cloning the database volumes, but all of the logs and control files as well. Now, when we go back to the command line interface for the RHEV server, we see that the clone database has already been mounted, started up, and is fully operational. In this last demonstration, we'd like to show what happens when you live migrate a running database. We're running Benchmark Factory to simulate 100 users against a TPC-C transaction, and we're going to allow it to run before, during, and after the live migration without stopping. We start by showing the virtual machine in RHEV. Then we show that the database itself is healthy and running. Next, we show Benchmark Factory, including the graph highlighting the performance. Now we're going to trigger the migration. As we can see, there's no discernible difference in performance, even though we've already started the migration process. We can see now that the migration is complete and there's still no drop in performance during any portion of the live migration. Now, let's move into the future of RHEV and NetApp integration. Red Hat is currently working on a plugin framework so that third parties can more easily integrate with Red Hat Enterprise Virtualization, and expects that the framework will be production ready with the 3.2 release of RHEV, which is currently slated for the first half of 2013. NetApp is working with Red Hat not only on that framework, but also with a NetApp plugin that we are currently referring to as VSC for RHEV, or Virtual Storage Console. We are also targeting the 3.2 release of RHEV. This first release will have the following features for NFS-based storage domains: the ability to discover NetApp controllers, the ability to provision new storage from RHEV, a NetApp tab in the RHEV web portal, and the ability to rapidly clone virtual machines for NFS-based storage. In other words, offload cloning. So where is all of this work being done? In short, the work is being done in the Overt project. Overt was launched by Red Hat and IBM in 2011 and is the upstream project for RHEV and the KVM ecosystem. Along with folks from Intel, Cisco, and others, NetApp is on the Overt board and has developers working with RHEV and Overt in order to further the integration. By working with Red Hat on Red Hat Enterprise Virtualization, we maintain a more traditional approach to the strategic partner relationship with Red Hat. This includes submitting bugs, feature requests, building joint solutions, joint presentations, and other outbound activities. On the other hand, by involving ourselves in Overt, we provide a more long-term influence to KVM and RHEV. Finally, if you'd like more technical information on Oracle and Red Hat in the context of NetApp storage, please visit the NetApp Technical Library and review the technical reports listed on this page.